Electron structures of atoms. So electron structures of some of the atoms are given in this slide. You can see that hydrogen with one electron is placed right here. Then the helium is here with two electrons. So every element in the periodic table try to mimic some of the electron configuration similar to the ideal gas electron configuration, because it has either closed shells or closed subshells with electrons. As you can see here, only one electron there in the hydrogen, and if hydrogen wants to be similar to helium, it would be looking for one electron so that it could reach the same stability as the helium. And here in the place of lithium, you can see that one closed shell and you have one extra electron in here. So lithium would be looking for some element which could take away its electron, or to which the lithium could give away its excess electron and behave like a helium. So similar fashion, as you can see in this column, every element in this column right here has at least one excess electron. And these elements will be looking for a non-metal which would be ready to accept the electron from here. And as you can see in this column right here, these are all non-metals. You can see this right here. If it has one extra electron, it would have become a closed shell. In here also, you can see that it is short of one electron to become a closed shell. Similar fashion, bromine and iodine too. So all these elements are looking for an element which would be accepting the electron, and all these elements will be looking for a partnering atom which would be ready to give away the electron. So that is the reason these metals and non-metals react together to form electron configuration similar to the ideal gas electrons configurations. So as I already told you in the previous lectures, that it has subshells are called S, P, D, F, and S has the maximum capacity of 2 electrons, P has the maximum capacity of 6 electrons, D has the maximum capacity of 10 electrons, F has the maximum capacity of 14 electrons to accommodate the electrons in its valency. Electron shielding, you can see here the first orbit right here is closed, and second one has the maximum capacity of S2, S2 and 2p6, which is 8 electrons, and a total of 11 electrons. So sodium has 11 electrons because sodium's atomic number is 11, so it will have 11 electrons. So and 11 protons, as you can see that these are 11 protons right here. So you should have 11 electrons in here. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So if this is removed, then this will become a stable element just like helium, because helium is the closest atom to sodium. So it would be trying to get rid of that excess electron so that it would behave like helium. And you can see this chlorine right here, it has 17 protons right here, so it should have 17 electrons in its orbit, and when you count it, it will be all 17. But the closest element to chlorine is argon with 18 electrons. So if chlorine wants to act similar to argon, which is the 18 electrons, so this chlorine will be looking for any atom which would be ready to give away its electron. So when sodium and chlorine are mixed together, the sodium gives away its electron and chlorine readily accepts that electron. So sodium becomes Na plus because it has one extra electron, because it gave away one of the electrons. So it would have 10 electrons and 11 protons. And once the chlorine accepts the electron, it has 18 electrons, which is one negative charge in excess, and 17 protons because nothing happened to the protons. So number of protons will remain in sodium and chlorine as they were. but the sodium will get rid of one electron and chlorine will gain one electron. So sodium will become Na plus ion and chlorine will become chlorine minus ion or Cl minus ion because it got one extra charge. Sodium lost one charge, so it becomes a positive ion and chlorine becomes a negative ion. So the next one is the covalent bonding, and earlier, so when the sodium and chlorine react are added together and forms NaCl, the bonding between the sodium and chlorine is called the ionic bonding because they become ions and they bond, so we call it ionic bonding. The next type of bonding is the covalent bonding. In covalent bonding, when one or more pairs of electrons are shared by two or more atoms. So when you have two elements which are not really ready to share, give away its electron or gain completely electron, but they share the electrons with the neighboring atoms, then we call it covalent bonding. As we already know that number of electrons in hydrogen are 1. So hydrogen would be looking for another atom which can give it one more electron so that it becomes helium. So it will go close to another hydrogen atom. So this hydrogen will feel that the atom which this hydrogen has its own. So this will be shared among this, and this will be shared among this in this. So in other words, this hydrogen will feel this hydrogen has this atom or this electron already, and this hydrogen, when it is very close to the another hydrogen atom, this hydrogen will feel that both the electrons belong to this, and this hydrogen thinks that these two electrons belong to this hydrogen. So they both become stable by forming hydrogen atom. Ionic bond is formed when electrons are transferred between two or more atoms and the resulting ions of opposite charge attract each other. Ionic bonds usually do not form molecules but aggregates of ions attracted by charge. So as we already discussed, when sodium and chlorine are added together, sodium becomes Na plus and chlorine becomes Na minus. And then sodium chloride is formed. So when these two are added together, so you will have sodium as it is and chlorine as it is. So whatever the superscript which is plus is nothing but plus 1, and Cl is nothing but Cl minus 1. So this will be transferred to the subscript of sodium, and this will be transferred to the subscript of chlorine. Since they are 1, it becomes Na1Cl1, which you can write it as NaCl. When it is just 1, you don't need to write it. So it's NaCl will be the new formula of the compound which is formed by adding sodium and chlorine. Covalent compounds are the substances whose atoms are joined by one or more pairs of electrons in a covalent bond. So whenever there is any covalent bond between two atoms and they form a compound, that compound is called the covalent compound. Polar covalent compounds are those in which the shared electron pairs are closer to one atom than the other one, making one of the part of the molecule relatively negative, the other one is relatively positive. So when two atoms are sharing the pair of electrons, one of them will be, let's say that one of the atoms is a big, um, big bigger atoms. So one of the examples, let me give you an example, which is water. We all know that hydrogen and oxygen are the elements make the water compound, right? So hydrogen has 1 electron and oxygen has 8 electrons. When a water molecule is formed, hydrogen and oxygen, they come together and share pairs of electrons. So when that is happening, since we know that hydrogen has only one electron, and when it has only one electron and one proton in it, then obviously it is easy, and then oxygen having 8 protons in it is going to attract the electron which is shared between hydrogen and oxygen a little bit stronger than hydrogen. So then that electron will move a little bit close to the oxygen atom by making the oxygen atom as a negative charged ion and making hydrogen as a positive charged ion, because that electron kind of moves close to the um, oxygen atom. So it becomes, that's what is the polar covalent, because even though it is not completely taken away from hydrogen, but still it is since a little bit closer to the another atom. So bonding is formed, and that is called the polar covalent bond or polar covalent compound. Organic compounds are the covalent compounds that contain the element carbon. So any compounds which has the carbon in it, we call them organic compounds, and all the organic compounds are covalent compounds. Ionic compounds are formed by electron transfer, and usually crystalline solids with high melting points. Whenever the ionic compounds are formed, they are crystalline solids with the high melting points. And some ionic compounds contain a metal and a single nonmetal. Other contain a metal and atomic group consisting of 2 or more nonmetals. As you can see in this example right here, you have 2 sodium ions right here with the sulfide. So you have one excess electron right here, you have one excess electron right here. So these 2 atoms together give the 2 extra electrons which the sulfur would be looking by forming sodium sulfide. So you can see that one from here, one from here. Now as this sulfur gets 2 electrons which it was looking for to become argon. So it could be, as I already said, it could be one or more metals reacting with nonmetals. When a metal atom combines with the nonmetal atom to form an ionic compound, the chemical formula of the ionic compound formed can be determined by knowing how many electrons the metal atoms lose and how many electrons the nonmetal atom gains.